Okay, graphs. So we're going to look at some motion graphs, and we're going to look at three different flavors of motion graphs. One is displacement, the other is velocity, and the final is acceleration. And let me talk you through these. So the graphs should tell you a story. So you want to be able to look at a graph and sort of be able to make a story from it and describe the world. So the graphs in physics are always representing something about the world. Sometimes it's more obvious than other times, but for the motion graphs, hopefully they'll tell you something. So here's an example. So I have a motion graph here. So this is things I want to look at. First, I want to look at the axes. So this is telling me time. So time is going along the x-axis, and this is distance. So this is how far I am from some point. So right now we're dealing with motion in one dimension. So does it tell me how far away I'm getting? So let's make a story. So here I am. I'm at my house. There it is. It's 20 microns across. And I'm going to walk away from it. And I get further away from my starting point, right? So this is my starting point, my zero here. And I'm going to think about this as a number line, right? So one direction is going to be positive. The other direction is going to be negative, right? I could have negative displacement. So I'm going to start here. I'm going to walk away. I walk away. And at some point, right, this is my timeline, at some point I stay stationary. Right? So we may look at like oil drop diagrams, right? So if I can imagine that if I every second I dropped a seed on the ground, or every second I put a drop of oil on it, right, I see a dot, 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 dot. So I'm moving steadily away. And then I have a pile of dots as I stand in one place, right? So my distance isn't changing. So I'm staying in the same place as time passes. So I'm standing still. And I'm talking to the neighbor. I'm looking out in the yard. I'm thinking about what I'm going to do next. Then I continue further away. Right? So I'm going to go at a steady state till a little bit further away. And then I stand still for a little bit. And then motion in one dimension, right? So this doesn't mean like I'm looping around or going off. This means that I'm returning. So I'm steadily returning back to where I came from. And I'm going to do it at a faster rate, so my dots probably be further apart. So each of these graphs should tell you a story, should tell you about motion, right? So here I'm getting further away. Here I'm standing still. Here I'm getting a little bit further away. Here I'm standing still. And then I'm returning more quickly to where I came from. So some mathematical quantities that we want to look at when we're looking at our graph. So the two things I'm going to think about whenever I have a motion graph, and two things I'm going to think about, maybe what does the slope tell me, and what does the area under the curve tell me, right? So the slope in this case, right, the slope is the rate of change. So what's the rate of change of distance over time? So distance over time, that's going to be velocity. So this is telling me velocity. My slope it's going to be velocity. So here I have positive slope, so I have positive velocity, or I'm getting further away from my starting point. Here I have zero velocity, so I'm stationary, I'm not moving any place. Here I have positive velocity again, so I'm getting further away, and then zero velocity. So again, I'm looking at my slope. The slope of the line is positive, the slope is zero, the slope is positive, slope is zero. When I return, I have a negative slope. So notice that my displacement is positive, right? I'm still on the positive side. Here's my house. I'm out here, but I'm moving in the opposite direction, right? So my displacement is positive and my velocity is negative. So signs don't have to match. And this is especially going to be true when we get to acceleration. So I can have positive velocity, negative acceleration. I can have negative velocity and positive acceleration. These things happen all the time, but you just have to think through it. So anyway, so that's the slope. The slope tells me something useful. So what does the area under the curve tell me? Well, area under the curve, the way I'm going to think about this, like what does it mean when I have meters times seconds? Yeah, I got nothing, right? So it doesn't tell me anything. So my area under the curve, not helpful, right? But I'm going to think about it. I want to think about it for every graph I look at. I'm going to look at these two things, right? My slope is going to be meters per second, so rise over run, so meters per second, that's velocity. The area under my curve, yeah, it doesn't tell me anything useful here. Okay, so look at another graph. So here's a graph. Guess what? Displacement and time. Can you come up with a story? What's going on here? Okay, a couple of things I want to notice from this. So first thing I want to notice is that I'm not starting at the origin. Nothing says I have to. I can start wherever I want. And in physics, right, there are some things that you get to set. We set time arbitrarily to be 0 at the start of the experiment, most commonly, but you could change it. We set displacement to be 0 where it's convenient. But in this case, 0 is not convenient at the beginning, so we're going to set it, so I'm starting at some distance away, right? So if I'm thinking about my house analogy, here's my tiny micron, 20 micron house, right? This means I'm starting here, right? This is where I'm starting. I'm starting away from my house on the positive side, right? So I'm going to say this is 0, and I'm going to say this is positive, and this is negative, right? Look at a little tiny window, and a creepy kind of closet, and some ghost up there. Okay, so now I'm going to move further away from my origin, right? So I'm going to move in this direction. I go dot, 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 dot. Here I am. I've moved in this direction. And then I don't stop. I immediately turn around and start going in the other direction. I go back the other direction. And then I do stop before I get to my house, check the mail, and then I go inside. Right? So each of these graphs should tell you a story. I want to look at this again. What is the slope mean? In this case, I have meters over seconds. I'm going to recognize that as velocity. What does the area under the curve tell me? Well, I'm going to have meters times seconds. And yeah, I got nothing on that. So what does this tell me? My velocity is positive. Right? I get further away from my origin. I have a faster negative velocity, right? So I'm speeding more quickly as I go to the house, and then I stand still. I have 0 velocity, and then some negative velocity to get there. That's all I got. Okay, we'll talk to you soon. Bye.